Hi, everyone. Thank you for coming. Hope there's not going to be any feedback. Basically, like he said, my name's Eric Pickup. I work for Manwin Canada. Sorry, Manwin. I've been here for 4 years now. I started at the company as a web developer, and since then I've worked in several departments, but I've stayed mostly on the IT side. Sorry, let me get some water here. In terms of work history, I've been in web development now for about 14 years. I got the bug early when the internet was new, and I wanted to build a website. I don't know why. Back then, we were still using Netscape 1, but I just wanted to build a website. I didn't know the topic. I didn't know what it would be about, but I wanted to build a website. So back then, there was really no software to do this kind of thing. Sure, my first attempts, I put up a bunch of static HTML pages, but you want to do more than that. So I literally learned to program specifically to build a website. Any website, just a website. Over the years, I've done many new things since then, but I've always worked in web development. And over time, the projects I've worked on have grown and grown. But I'll have to say, the latest project has really forced me to think beyond anything I was ever expecting to be working on. So when I joined Manwin, there were about 70 employees. Since then, over the last 3.5, 4 years, I've seen it grow to almost 500 people. There are now over 150 people just in IT at Manwin. In the last week, we added 3 IT people alone, as well as another 10 employees in other departments. So as you can imagine, it's a very dynamic environment. You started off as a company where you knew everybody's name. Now you want to know everybody's name in your department. So basically, the topic today will be how to build a website to 100 million page views and beyond. In fact, while we were doing the research for this project, we actually realized that my initial numbers were lowballing it because we overlooked certain other things like mobile devices, APIs, RSS feeds. All these things hit the web servers too. And obviously, they have to be accounted for in our traffic numbers because they affect our technology choices. Today, I'll be dividing my discussion into 4 sections. First, the context. The idea being what we're doing, what it's about, and what we needed to accomplish. That blends into the second one, which is the requirements. Finally, I'll address the architecture we finalized on, we built, successfully deployed. And then, finally, we'll go over the good and the bad of the project, what we learned, and what you guys could learn from us in building your own projects. Now, I suspect a lot of you, after seeing the name of the presentation I was going to be doing, Googled my name, Eric Pickup, a very easy to remember name, just to wonder, who the hell is this guy, and what right does he have to talk about this? Well, I work for youporn.com. I'm IT lead for that site. And over the last 6 months, we basically rewrote it. In April 2011, Manwin acquired it, and that's when I came in. YP is a video sharing site like YouTube, hence the name, but is obviously for adult content. This was the first major tube site, and probably one of the few of the ones from the early days that still survive. There have been many copycats since then, and since then Manwin has also acquired a lot of them. Just to give you an idea of, by the way, that's the only slide that even mentions porn. This is perfectly family-safe presentation. Yeah. Sorry, guys, I had to promise the organizers. I was tempted to sneak some slides in there, but I figured, it wouldn't be a good idea. I'd never get invited back. Just to give you an idea of where we rank in terms of traffic, according to the Alexa rankings, Netflix is number 93, we're number 95. New York Times is 102, and Reddit is 119. The graph you see on the screen is based on Alexa's estimate of traffic numbers. That's where I got the relative sizes there. And even though it's not the topic of my presentation, just to give you some idea of the bandwidth we use 100 gigabits per second, which is the equivalent of 3 DVDs streamed every single second. Or, to put it another way, 900 terabytes per day. these are the issues we have to deal with at Manwin. And just to give you an idea, this isn't even the largest site we own. Okay, so this is what I took over about 9 months ago. It was a high-traffic website written in Perl with a very complex architecture. For the first few months, primary focus was maintenance, keeping the site running, making sure it didn't crash. You know, you don't want to buy a big site like this and then screw it up. And then planning a rewrite. We decided on a rewrite pretty early in the process because, frankly, I mean, I love Perl. I worked in Perl for 10 years before this. When I started developing in programming, Perl was the only way to go. PHP didn't even exist then. Microsoft solutions for web development hadn't been created yet. There literally was nothing else. So I learned Perl. I still love Perl. But the fact of the matter is, at the end of the day, finding good Perl programmers in Montreal or anywhere else is a real challenge. And I did not want to be the only one who ever could make a change on the website. So we decided early on that it had to go. Another part of it was the architecture. While it worked very well and it obviously handled the traffic, it was overly complex. For example, just to give you a quick overview, before a single hit managed to get to the web servers, it had to go through nginx, Perlball, which is a load balancer written in Perl of all things, nginx again, then squid, and then it hit the web servers. At each step, one of these things did something important that the other ones couldn't do, which basically necessitated having all of them. And there wasn't just one of these servers, there was many of them. So it was just way too complicated. Now, So the rewrite started in August 2011, and it was originally planned to finish by mid-November. Just to give you an idea, it actually finished in January, so things didn't go 100% as planned. But as I'll discuss later on, there was things that came up, which always happens at a project. Now, part of the additional challenge here was the fact that we had to maintain the old site while we did all this. And we even had to make changes on the old site, normally you'd say, okay, you make the change here on this part of this site, I'll also make it here. But sometimes we weren't even ready to do that feature on the new site. We didn't have the feature, so we couldn't even change it. So it was very complicated to handle this process. It was a constant point of, making to-do lists and having two lists and keeping track of what had been done on each one. So that was obviously a big issue for us. Additionally, staffing issues. Now, as a company the size of Manwin with 150 people in IT, you say to yourself, okay, these guys can grab developers from everywhere. But we have a lot of projects. And so in the end, the project we decided to work on and the technology we were going to use required some specific knowledge, which meant sharing resources between projects and then coordinating with them. Now, one of the main requirements, aside from managing the traffic, was to make the process 100% transparent to users. We decided from the very beginning that we weren't going to announce to users that we were changing the site over in any way. So whatever we did, the users could not know we made a change. So this meant even simple things like even if there was a usability bug on the site, we wanted to maintain that usability bug. Obviously, any serious bugs were fixed and patched, but little things like, you click this, why doesn't it act that way you'd want it to? We actually had to replicate that in the process. Now, during this process, we looked at different options for how to rewrite it. It's very often that anybody is given an opportunity to have a complete clean slate to rewrite a site as important as YP. So we took this opportunity seriously. I mean, it's an opportunity that doesn't come up every day. I'm sure most of you know this. It's very rare, unless you're working on your own small projects, to actually start from scratch and have no real rules except for the basic requirements. So we were very open-minded. We looked at .NET, we looked at Java, we looked at a bunch of different options within using PHP. At the end of the day, it came down to resources. While Manwin has departments working in Java and .NET, most of the core team still works in PHP, and it was going to be easier to stick with PHP in this case. Plus, I mean, on my previous work at Manwin, I had actually managed to pick up PHP pretty well. So it helped, I was biased in that direction, I'll have to admit myself. Although my work in the past with Java has been, fun. So at the end of the day, this is the architecture we ended up deciding to go with. Now this is a replacement for the old architecture. Now, having started off saying that the old architecture was overly complicated and we wanted to get rid of it, we ended up with this, which probably is even a little bit more complicated. But it simplifies things in important work-related ways. So just to give you an idea, I'm just going to go over them really briefly. I'll be giving a lot more details later on. Proxy is a load balancer, which spreads the load across multiple Varnish servers sitting behind that, which I'll introduce in a bit. It writes to syslogng for certain tasks. And then basically any request that Varnish itself can't answer, it passes off to nginx, which is our primary web server application server. It then communicates with MySQL or Redis, and we use Proxy again to load balance between different Redis nodes. ActiveMQ is a messaging component, which I'll discuss when we get there. Now, an important part of this, obviously, is you have to look at the risks and rewards. This is a high-profile project, and failure would be noticed. We needed to get this right. So each component, as we came to it, we looked at, is it worth the risk, or should we go with a simpler LAMP-based solution? Most projects out there today are based on LAMP, Linux, Apache, MySQL, and PHP, Perl, or Python. This is the common interface for people using PHP. It would not work for our needs. It's just not scalable enough unless you want to throw a lot of servers at it. As I explained, we did look at other options like .NET and Java. Another option, of course, was just to throw hundreds of web servers at it. That would have worked. But who here would want to maintain it? Who would want to deal with that every day? We actually have some sites that we've acquired that do work along those lines, and they're a nightmare. It's not something you want to replicate if you have a choice and you plan to need to grow to scale. So first one that I'll look at is Proxy. I'm not going to handle these slides in terms of the importance to the project, but rather in terms of how the request is handled. So the first thing the user hits is the first thing I'm going to talk about. In this case, it's Proxy. Proxy is a load balancing solution. It basically, as I mentioned, it spreads the load across multiple servers standing behind it, which are in this case are Varnish. It's basically fast and reliable. And it, just in case anybody doesn't know, load balancing is basically this process. There's also a common type of load balancing other sites use, and is often the first load balancing solution smaller projects encounter, which is DNS load balancing, round-robin DNS. In fact, the old YouPorn actually used this process themselves. And it has its advantages. It's very simple. Most of the work is done on the user end, because when they request, they type in the domain to their, in their browser. The web server returns multiple responses, and then the user's computer decides which one to hit. Problem is, if one of those servers gets overloaded, dies, or crashes, you're stuck. People are getting stuck to it, so a certain percentage of your traffic is just not hitting your site anymore. We wanted to basically do better in this case, and early on in the project, Proxy was decided on to use that. It's extremely fast. It basically will serve connections up to the limit of the hardware itself or the capabilities of the back-end servers. Okay, the next one I'm going to look at is Varnish. Varnish is really the glue that holds the site together. It doesn't generate the pages. It doesn't, like I said, it doesn't generate the pages, doesn't connect to the database. But what it does do is allows us to scale. It keeps the load off of the web servers and off the databases. It also does certain other important tasks, which I'll discuss next. So like I said, it's a reverse proxy. It's a reverse proxy optimized for speed. It's similar to Squid, which some people might know about, Squid is being one of the most popular load balancing solutions out there. Unlike Squid, however, Varnish is designed to maximize the performance of a single website. To do that, all caching is done in memory, not on disk, so it never hits the hard drives. Its configuration is extremely flexible. It allows complex conditions, regular expressions. It's also very extensible with a lot of external libraries written by third parties. And we use some of those libraries ourselves. In fact, we've tested them, some of them at higher loads than anybody's ever used these libraries. And I'm sad to report that we had to put in quite a few bug reports because of that. In fact, there was a few that we even decided not to use. What do we do with Varnish? First thing we do is device detection. We need to know if the user is using a mobile phone. If so, we handle that and send them on their way to our mobile site. We do GIP detection. We do session management. Because most requests do not hit the web servers, anything that has to be done for every user has to be done at the Varnish level. It also does URL normalization. With a 5-year-old site, you're going to have a lot of ugly URLs out there. People have add things to websites. Now, you want these URLs to still work, but you don't want them to pollute your cache. Because the way Varnish sees it, every URL is taken along with certain other conditions like the device and GUIP, and basically stuck in cache using a hash. But if the URL is different on each link, for example, somebody puts a !1 at the end or something odd like that, you're going to end up with extra garbage in your cache. Now, as fast and as efficient as Varnish is, it is limited by the amount of memory on the system. Now, so you really want to streamline it and make sure there's as little garbage in Varnish as possible. So this is one of the most important steps, is just analyzing your site and figuring out what URLs you're going to accept and what changes you have to make in order to get your caching strategy to work. So as I mentioned, cache management takes an advantage of language and device, and it also does ESIs, which are edge site includes. You may be wondering what these are. Anybody who's worked with Apache for some time, especially if they're a bit more old school like me and they've used CGI, they're like server-side includes, but at a caching level. These were actually invented by a CDN company, content delivery company, and made an open standard, which Varnish now implements. Finally, it does health checks on servers similar to HA Proxy, although not as good, which allows us to basically load balance between the back-end web servers without adding an extra layer of HA Proxy in there. Next up is syslogng. Syslogng is an open source replacement for the plain old syslog. By this point, if you're using a Linux system, there's a very good chance that you're using syslogng and don't even know it. It responds to all the commands that syslog does, and basically it's just a logging tool. It's for logging logging to plain files with no logic or thinking involved is adequate. For us, the logs are anonymized with basically a session ID. And then basically, after that, what we do is we use the logs to handle view counts. For view counts, we have a Perl-based script. See, I couldn't completely get rid of Perl. And what it does is it just listens on a socket to syslogng, collecting information, and periodically forks off and updates the databases. Finally, we also look at things like related videos, where if more than X number of people view the same video, we assume the videos are related. nginx is the next level of the stack. Basically, this is our web serving solution, and basically it's what Varnish goes to if it can't answer the request satisfactorily by itself. nginx is very high performance, and it has very good integration with fast CGI, which was important for us since we wanted to use fast CGI because it offers performance benefits over other solutions. And even with Varnish sitting in the way, with 200 million requests per day, you're just still going to get a lot of traffic, even at 99% efficiency, which is not achievable ever, even no matter what the Varnish guys tell you. You're not going to be able to receive handle that kind of traffic unless you use a very efficient applications on your application server. nginx is event-driven, unlike, say, Apache, which is thread-based. And because of that, it very well handles memory. You don't have to worry about, as your processes mount up and there's more and more requests coming in, that you're just going to run out of memory. nginx solves that problem. And like I said, it has a very good tie-in to PHP FPM, which was important to us. These machines are used mostly as application servers. They do serve a few static files, but pretty much everything else is directly piped to PHP FPM. For our framework base, we decided to use Symphony 2. At Manwin, over the years, we've written many frameworks for different websites. We've experimented with a lot of the open source ones, different options. At the end of the day, we found Symphony 2. And I'd have to say we were very impressed. It's very fast, and it's very fast to develop in, and surprisingly fast for a heavy framework. There's a lot of code optimization and caching, which greatly improves performance. Another nice thing about Symphony 2 was the fact that it tightly integrated with Twig. Twig is a templating language. Now, before this project, I personally was completely against templating languages. Why use a templating language in PHP when PHP's whole purpose is to be a templating language? Well, Twig is the answer. It basically solves a lot of so many problems that PHP allows to happen, especially if the people doing the HTML and design of the site tend to be less technical. But if you want them to be able to generate some simple loops and do so safely, echo input, do so safely, Twig really allows that. But it still allows the flexibility, and it still is extendable enough that you can do the big jobs with it. And like I said, I've now become a personal lover of Twig, and I will never not use Twig again in another project. Just for the reference, by the way, Twig was actually very important to us because part of this obviously required a complete rewrite of all HTML on the site. So in that process, we decided to go HTML5 standard and clean everything up. We use CSS. Our CSS is optimized, and so is our JavaScript. Everything is as clean and as compliant with browsers as we can make it. I want to congratulate the guys who did that, because obviously I didn't. It's not my specialty. You wouldn't want to see what I would do. Center tag here, bold tag there. Another important thing with Symphony 2 is it has a wealth of bundles included. Many of them are included, but with the default install. But many of them are available for download on the internet. They're all open source, and some of them are very useful. In this case, I don't believe we used any bundles on the website itself. However, we developed an entire CMS with it in 2 weeks, making large use of these bundles. Symphony 2 is very consistent internally and logical, and so it's very easy to figure out, which luckily balances out its one key weakness, which is the lack of comprehensive documentation. Unfortunately, when you Google Symphony and any problem, you're going to get Symphony 1 information. A lot of that is some of that's directly translatable to Symphony 2, but a surprising amount of it is not. So Symphony 2 is getting better in this regard, but it still hasn't had the wide adoption as Symphony 1 has, so hopefully that will improve over time. Next up is ActiveMQ. I mentioned this earlier in the presentation, but I didn't really go into any details, because this one is probably something most people haven't heard of. ActiveMQ is a Java-based messaging component put out by the Apache Foundation. The idea behind it, is fire and forget. You send off a message, and ActiveMQ is listening for it, and dispatches it to listeners. Those listeners can then do whatever task you need them to do. In our case, because we had to maintain two data sources, both MySQL and Redis in real time, ActiveMQ was very attractive to us. And it's very high performance. So even though we don't send a lot of messages, that's still a relative thing. We still basically do many updates to the database, even in the most optimized way. So, like I said, ActiveMQ is very enterprise-type software, and it seemed very promising. And, sorry, yeah. Unfortunately, it didn't really work as well as we would have liked in our case. The development with it was too rigid because of our rapid development environment. We're a PHP company. Our programmers think like PHP developers. We rapidly prototype, test, and deploy. ActiveMQ is not designed with that kind of programming in mind. It's designed for a long planned development process with a lot of flow charts and a lot of preparation. Making changes to it is very complicated. And as I mentioned earlier on, the Java developers working on it were a shared resource, so we didn't have them full time. So we had to communicate with them, and it became very problematic. So in the end, we actually moved back, and the web servers themselves do some writes to the databases themselves at this point. This is not to say ActiveMQ is a bad product. I'm actually quite impressed with the way it worked. It just wasn't a good fit for our environment. If you're working in a different environment, or especially if you're already a Java shop, it's definitely something you want to look at, because it is a well-designed tool. So again, we're back to HA Proxy. I'm not going to waste your time again with too much on this one, except to add one special reason why this was appealing to us. HA Proxy supports the concept of pools of servers, and basically can automatically fail over from one pool to another in the case of failure. For Redis, we have two pools. We have a write pool, which is one server, and a read pool, which is multiple Redis slaves listening for updates from the master server. What we wanted to do was automate the failover from the master to a secondary master in the event of a failure. This was important to us because obviously this is needed real time on the website. Finally, we come to Redis, which is the primary data store for our site. This is the first attempt we've made at doing this, of not using MySQL as the primary data store, and then using a caching layer like Memcache or Redis behind it, in front of it, sorry, to cut down on the load. What does this mean? It means whenever there's a query from the website, it connects to Redis and gets the answer. If there's no answer there, then there's no answer. It's a 404. Redis is the only connection made. Now, this is obviously a NoSQL solution, but it's not a caching solution. Redis can be used for caching, but its primary focus is not on caching, but on being a persistent data store. And that's how we decided to use it, although we also use it for some caching. Now, in deciding to investigate a NoSQL route, we also looked at, for example, MongoDB. MongoDB was attractive because it has tight integration into Symphony, sort of similarly to how Twig is. Redis, on the other hand, at least at the point when we were working on it, didn't have integration into Redis, and we had to write our own code to wrap it. MongoDB just wasn't as performant for our needs as Redis was. For us, it's all about lists and objects. And obviously, Redis is obviously designed to do that, which I'll discuss in the next slide. So Redis is a data structure server. While it does do key value pairs like Memcache, and in case you don't know, Memcache is a key value store done in memory, just like Redis. However, it's not persistent. So if, for example, it crashes, everything's gone. So you want to use it as a single data store. What you do is you grab your information from somewhere else, stick it in Redis. And you check Redis. If it's there, great, return it. If not, you fall back to your primary data store. And that's pretty much all it does. Get, set. That's pretty much the limit of its feature set. Redis, on the other hand, supports many data structures. It supports strings, which is actually just what I just mentioned. Except the values can be of any type, including binary data. In our case, we don't use it like that, but in fact, we don't use this too much at all. Hashes are similar in a way, but instead, basically you have a key again, but the value is another hash. That hash can contain arbitrary fields, and each hash can actually contain different fields. Again, because this is a NoSQL solution. This is not tables like MySQL. And you quickly, when you're working with Redis, you want to forget what you've learned from MySQL. This is perfect for storing objects. And in our case, for example, all our videos are stored in hashes of hashes. Then we have lists, which is basically a list like you've probably learned in school, where you can push into it, pull out of it, and iterate over it. And that's basically the limit of what you can do. We don't actually use this data set, this sort. Sets are unsorted sets that maintain uniqueness within them. This is convenient, for example, if you're dealing with a large set of data and you want a quick and easy way that's scalable to basically pick out the unique elements. You can just push them in. If it fails, you know it's already in there, you move on. Then finally, sorted sets. Sorted sets are actually the most useful feature in Redis from our point of view. Basically, they allow us to store sorted lists of whatever we want, and all sorting is handled internally by Redis itself. When you add to a sorted set, you give it an ordering number and a value, and Redis takes care of the rest. After that, you can count all operations on it. You can count on being ordered. Just to give you an idea of how fast it is, at one point when we were doing load testing at the beginning, we actually had it up to 50,000 requests per second on one machine. That was pretty scary. In fact, it overwhelmed our network capacity and we had to stop. Now, like I said, it is a primary data store, and we've actually gone so far as to store certain things in Redis that are not in MySQL, although most of the data is replicated there. One feature you got to watch out with for Redis that's important to consider is how to make it persistent. Obviously, I've said the best feature of it is persistence. Well, the problem is, how do you write to disk while still keeping up good performance? The answer is they have two solutions. One's RDB, which is like a MySQL dump, and you might be familiar with, which is a point-in-time copy of the in-memory structure to disk. This is very, very I/O intensive with any large database, and so you have to time it carefully and decide how often you're going to do it. Initially, because obviously at YouPorn, we want it to be very safe with our data, but we want it to be fast also. We still get a lot of requests on Redis despite all the caching we have in front of it. So what we did is we put it to every 10 minutes. Didn't work. It basically overwhelmed the RAID controllers on our server. So we've basically spread it out a bit. But there's another type, which is AOF, which is incremental. So as a write happens, it appends to a file on disk. This causes almost no load on the disks, especially since a site like YouPorn is mostly read-only. There are writes, but in comparison, it's not even close. Problem is, if one of these machines goes down, rebuilding the data set from one of these files is very, very slow. So this solution is probably best if your data set is small, or if you have enough redundancy so that you can run for hours with one of your machines down. Because you can't count on it being back up in anything less than hours. The documentation for Redis actually suggests a compromise between the two, where you do the RDB periodically, like daily, and then in between you do the incremental, which is actually somewhat what we've done with different backup times. Now, the problem with Redis, like with Varnish, is it's memory-based. It never reads from disk. And you really, really, really don't want it hitting swap. Trust me on this one, performance goes right to the ground. So because of this, you always have to make sure you have enough memory capacity in your servers. This was actually a problem we had because right at the beginning, we took a look at our database tables. We said, okay, we want these tables in Redis. This is how much memory, put this in our servers. Didn't work. We started importing the data, and we quickly realized, oh no, that's not going to be enough. So this is something you have to keep in mind when planning a deployment. You're going to need a lot of extra capacity unless your data set's very small. Now everybody here, I'm sure, is very familiar with MySQL. Everybody here has probably designed a website with MySQL. We've designed many websites with MySQL. You know, it's just the fact of life if you're doing web development. So we didn't want to get rid of it. Obviously, Redis, as great as it is fairly limited. You can't do ad hoc reporting with it, for example. So if you find if you have to ask a question that you haven't already thought to pre-populate a list with, you're basically back to doing the equivalent of a table scan and scanning through all your objects. You really don't want to be considering that. So MySQL exists basically for reporting and for when we want to add new features to the website and need to generate new lists. That's what Redis and MySQL exists for. Now, one of the nice things about not using MySQL in an active capacity on the website itself is we've been able to normalize all the tables to have clean data. This is something normally you can't do on a website because the performance penalty is too high. But in this case, we decided it was worth the effort just to better handle complex queries that might come up. You never know what management's going to ask for next, right? So basically, I have a bit of a background in business intelligence. I'm no expert in it, but I spent about a year and a half working in it. So I borrowed a lot of ideas for our database setup from that. So we use fact and dimension tables. And basically, this allows us to have very narrow rows so that more rows can fit in MySQL's memory at the same time. This greatly improves performance if you can do it. So at the end of the day, MySQL is not going anywhere. I don't believe any of the NoSQL solutions is in a position to completely replace MySQL, and it's certainly not going to happen at Manwin. Okay, so the good and the bad. So as I mentioned, our launch was 2 months late, and there was a lot of problems. There was a lot of problems we didn't really foresee. I believe we were overly aggressive in our timing, and we assumed these new technologies would be a lot easier to figure out than they were going to be. So that was really one of the big things. The other big thing is specific to one of the components I mentioned, which is ActiveMQ, which caused a lot of delays. There was a lot of, at the end of the day, we put off doing a lot of code because it was supposed to be handled on that side. In the end, we had to handle it all ourselves. That was a big unexpected delay near the end of development. As I mentioned, these are all new technologies. I mean, some of them, are a few years old, but they're in the grand scheme of things, compared to Apache and MySQL, PHP, they're pretty new. And there's not as much documentation out there as you would normally expect if you're used to these other technologies. So you have to be prepared to do some digging. You have to be prepared to dig through the the news groups and find this information. So there's going to be delays there. And I mean, as I mentioned at the beginning, risk was a big factor here. We didn't want to rush anything and then have it blow up in our faces later on. UPorn was just too important of a site to take that kind of risk. So we had to take our time and do it right. And as I also mentioned at the beginning of the talk, UPorn is a moving target. It was constantly changing. The data itself was changing. So we'd basically copy over all the data into our new database. But before the process of copying it over was done, the data was already outdated. And the process itself was too long to do post-launch. We had to have all the data in our database when we switched over. Because as I said, this was going to be transparent to users. So you couldn't have, for example, a video on the first page, and then they refresh a couple of times, and the video is gone. So we had to keep them in sync. This process alone, I think we pretty much underestimated the difficulty of how much time it was going to take, how much work we were going to have to do to do these incremental copies. Excuse me. But was it a success? Well, yes. I can pretty confidently say that, and I can pretty confidently say at Manwin it's been viewed as a success. We launched without any downtime. Now, that sounds great, but the fact of the matter is it was a very, very long day. I was there basically for about 12 to 16 hours to do this process, because as much as we wanted to do a cold switchover and to make our data syncing process work, it just wasn't possible. We had to run the data syncing while we did it, and we couldn't just throw 100 million page views at these servers and not expect them to die with cold caches. There would have been no pages in Varnish. There would have been nothing basically stored up in Redis. So we needed to basically do this slowly and basically do it. As we got closer and closer to 100%, and as the needles pointed up near the red line, it got pretty stressful. At one point, my boss, who was over there, actually ran to McDonald's to get me some food because I hadn't eaten in 8 hours. Those fries were pretty damn good. But yes, we did launch without any downtime. It was actually smooth. No users complained, and we have a lot of vocal users. You'd love to email us. No one complained. And the site is 10% faster, which, while was one of the requirements, I was never sure if that one was going to happen. Like I said, the old YouPorn was complicated. It used a lot of complex technology, but at the end of the day, it was well engineered, and it was actually well done. So I was never expecting to make a huge improvement there. So 10% is huge in my books. And we gained a lot of valuable expertise. Other projects in the company are now coming to us, but trying to learn from what we're doing, sometimes they may not be implementing a whole stack like we have, but they are basically trying to pick out the good parts that they think can help with their projects. So I really do believe that this has been a real success. So now, a couple of weeks ago, I posted on the Redis mailing list, just thinking I was going to let the Redis guys know that YouPorn was now using it. It went a little further than I was expecting. Apparently, the ConFoo guys got quite a load increase on their website for that day. But one of the comments that I got on Hackers News was it was going to be nice to see a keynote where they weren't trying to sell me on something. But I'll be honest with you, I'm trying to sell you on one thing. I'm hoping you guys might want to come to work with us. We're always looking for good developers, and as I've said, knowing these technologies are things we just learned recently, so it's not something we expect new people to know. So if anybody's interested in an exciting company that's growing fast and where you're going to see unexpected challenges, we have a booth outside.